I'm making this video to help people understand what's going on with FCC testing and video transmitters. There's a lot of confusion out there. There's companies that are claiming to have FCC certified video transmitters in the 5.8 gigahertz band and the 2.4 gigahertz band. But in fact, they're kind of cheating a little bit. Maybe they're just misunderstanding the rules. Maybe they're playing dumb. I don't know. But I want to dive into the technical requirements and why these things are not legal. First, I want to make a little plug for our website, techandstein.com. We put some stories up there. We don't do too many direct videos for the site, but we also use our Vimeo channel. This one I'm putting on YouTube because it's kind of a video response to another YouTube out there. Check out the channel RC FPV Flight, and he reviews some equipment. And this is kind of to talk about a product that he just recently reviewed. This product is a 5.8 gigahertz, 25 milliwatt video transmitter. Goes by the model name FT951. It's popular, and the misconception is that because it's 25 milliwatts, they were able to obtain the FCC ID you see there, and they proudly display that number. And I don't mean to pick on this particular transmitter. I've never laid hands on it. I have nothing against this company that makes it, or anybody that uses it for that matter. But it's typical. There's many of them out there. So the way a product like this gets an FCC ID is the manufacturer goes to a third-party test lab, not to the FCC themselves, but a private company, and they tell them, here's what we want to apply to our test. Here's how we want to test it. Here's the test method that we want to use when testing our device. And so the test lab does that. They test it and they sign off on it, say that yes, we tested it exactly the way you told us to. However, that doesn't always mean that it's a legal device and that the FCC would approve. The FCC, for the most part, doesn't review these tests. They just see that a recognized test lab has performed the test lab says it passed, and so they get an ID number issued to them. And if you take a look at the test method, this is kind of the first way that they cheat a little bit on it, is that this is a video transmitter. So to properly test it, you need to put in a video signal. So you need an NTSC or a PAL composite video signal going in the video in jack. And since it has an audio in jack, you also need to put in an audio signal. And there's standards for these things, like I don't know if it's a 1 kilohertz tone or exactly what it is, but you have to put in audio in there at a certain level, and that's going to cause the radiated emissions out of the device to be in kind of a worst case condition. You're even supposed to use 75% color bars because that's going to produce the worst pattern. But you can see here by their RF report for this device, they didn't do that. You can see the band they put in a very small signal that didn't take the modulation out much beyond a few hundred kilohertz. In fact, it says in there that they put the device in engineering test mode. So it was not transmitting video, it was just transmitting a small carrier. Here's a graph of a properly tested video transmitter device from another manufacturer. I won't mention them, not in this hobby space, just like an industrial device. But you can see this is what the radiated emissions is going to look like for an actual video signal. The video signal is very large. It's about 6 megahertz wide. So when you see this graph and you see 5 megahertz per division, and you see how much energy it puts out over quite a wide area compared to the way the FT951 device was tested, you can right away see how where they went wrong. There's a couple of different technical requirements for a device to operate in this 5.8 gigahertz band. One of them is power levels, and that's frequently misunderstood. If you're a spread spectrum device, either a frequency hopping, and they're specific on frequency hopping, like how often you have to hop and how many channels you have to hop on, or you could be a direct sequence spread spectrum, There's some cordless phones and stuff like that. That's another type of very specific type of modulation, neither of which is analog video. So if you're one of those two spread spectrum, it's a tongue twister, type of devices, you can radiate up to about a watt. It really depends on how much actually comes off of your device. But if you're not one of those, you're just an unlicensed low power Part 15 device. And the energy limits for that is very specific. It's 50,000 microvolts per meter measured at 3 meters. And if you go through some math, it works out to about less than 1 milliwatt coming out of the device. It depends on the antenna and some other factors, but 25 milliwatts would then be at least 25 times the allowable radiated power for unlicensed device like this as a video transmitter. There's also some very specific requirements for antennas. For the unlicensed Part 15 devices, the antenna, the language they use, I'll actually just read it. An intentional radiator shall be designed to ensure that no antenna other than that furnished by the manufacturer shall be used with the device. The use of a permanently attached antenna or an antenna that uses a unique coupling to the intentional radiator is what they want you to use, basically. Now, obviously, you can see in the pictures of this device, it does not have an attached antenna. And a lot of manufacturers have skated by the FCC, and the FCC seems to be okay with this, of providing a unique coupling by doing what we all hate, and that is the reverse pin SMA connector. The SMA connector would be considered a industry standard connector, but somebody decided to reverse the pins around so they don't fit together. And at the time when they started doing that, that may have been unique, but I think that that's probably going to not last too much longer, because you can buy adapters, you can buy cables, you can buy antennas with the reverse pin on it. But in the case of this FT91 transmitter, it's even worse, because they didn't even use a reverse pin SMA. It has a standard pin SMA, so the threaded barrel there has the female pin side. So that's standard. So you can see that it's not a unique connector. It's not a permanent connector. And something that just kind of bothers me is this section 6.2 of the measure of the RF report. The manufacturer stated the antenna is integrated into the main PCB and no consideration of replacement is given. So they feel that that meets a requirement. This is clearly not an integrated antenna on the PCB. It's an industry standard connector for an external antenna. So that part is pretty much just an outright lie. So that's the technical side on why these types of devices are not really legal for transmitting video on 5.8 gigahertz. You can get a little bit more legal if you have an amateur radio license, which is very easy to get in the US, and I imagine other countries too. But the practical side of it is, does it really matter? Is anybody really watching? And, you know, the bottom line is the FCC is, as far as government agencies goes, a fairly small one. They don't have a lot of employees. They don't have field people out there monitoring the airwaves to see what we're doing. It's a complaint-driven system. So if enough people complain that these types of devices are interfering with whatever they're doing, then eventually they may get around to investigating, but it's a really slow-moving system. So a lot of the foreign manufacturers of these things, most of them are coming out of China, are kind of taking advantage of that, maybe intentionally, maybe not, I don't know, but they're not really following the rules, and we're buying these things because they're cheap, and, you know, hey, the world moves on. That's it. Thanks for watching. Don't forget to check me out on tekkenstein.com. I've got a Tekkenstein channel on Vimeo. You can subscribe and like here on YouTube. Let me know if you want to see more technical breakdowns of different types of products or discussions or explanations. Leave some comments. Thanks.